When we multiply 2.3 times 1.7, we first multiply as if the decimal points were not there. Okay, so we just do 17 times 23 and we get 391. And then we place the decimal point in the answer. How could a student use estimation to determine where to place the decimal point if they have forgotten the rule about adding the number of places behind the decimal points in 1.7 and 2.3? Well, we say 1.7 times 2.3 is definitely smaller than 2 times 3. Okay, because 1.7, we can round it up to 2, 2.3, round it up to 3. So if both of these factors are bigger, then the product will be bigger. And if both of these factors are smaller, then the product will be smaller. So I could round down to 1 and to 2. Okay, so my product, 1.7 times 2.3, has to be between 2 and 6. And the only place I can put a decimal in 391 that will result in a value between 2 and 6 is if I put it here, right? So right now it's right here. If I move it left 1, 39.1, that's too big. 3.91, that's between 2 and 6, so it can go there. But if I move it again, now it's 0.391, which is too small. So the only place I can put it is right here. Explain clearly why it makes sense to put the decimal point where we do. Okay, so what I actually did is instead of using a 1.7, I used 17, so I multiplied by 10. Okay, and instead of 2.3, we used a 23, so we multiplied 2.3 by 10 to make 23. And then when I multiply those two together, we got 391. But 391 is too big by two factors of 10. Okay, so if I multiplied by 10 and by 10 again, that's a factor of 100. So I have to divide by 100 to get the actual answer. Divide by 100, divide by 10 and 10 again, that's 100. And so to divide by 100, when you divide the decimal point between, you have to move the decimal point 2 to the left, so you get 3.91. Okay, I also really like to do this with fractions. So 1.7 times 2.3. 1.7 is 17 tenths, and 2.3 is 23 tenths. 17 times 23, we know that that is 391. 10 times 10 is 100. And 391 divided by 100 is 3.91.